All right, guys, last video of the week. Got just a couple problems to do. Okay, so we got to verify. All right, so we're going to start on the left-hand side because that certainly looks a little bit more complex than the right-hand side. And I'm thinking maybe we can add these two guys together, okay, and go from there and see what happens. So it looks like I'm going to have a denominator that is formed by multiplying these two denominators together. So over here, I'm going to have to multiply above and below by 1 plus sine of alpha. And over here, it looks like I'm going to have to multiply above and below by 1 minus sine of alpha. Like that. Okay. So let's see on the left-hand side. Okay, when I multiply these two together to form a common denominator, notice that they are conjugates of each other. So I'm going to get a difference of squares. Okay, so I'm going to get 1 minus sine squared of alpha, which I like because that's something that looks like this will work out with a Pythagorean identity. Okay, so let's see. Over here, I take this cosine alpha and multiply by 1 minus sine alpha. Okay, so I'm going to distribute that cosine alpha. So let's see, I get cosine alpha minus cosine alpha sine alpha. Okay, over here I multiply the cosine alpha by 1 plus sine alpha. So again, I'll distribute that and I'll get cosine alpha. Let's see, I'll get cosine alpha, and that'll be plus cosine alpha sine alpha. So if we look here and here, those guys cancel off because they're opposites. And notice I can add these two guys. And that'll give me 2 cosine of alpha. Okay, so I have 2 cosine alpha all over 1 minus sine squared alpha. Okay, so I'm looking at this denominator here, and I am thinking, let's come down here. I am thinking my Pythagorean identity, sine squared of alpha plus cosine squared of alpha equals 1. And I need 1 minus sine, so that means I have to move this guy over. Okay, so I would get cosine squared of alpha equals 1 minus sine squared of alpha. So that means I can substitute cosine squared of alpha in for this. Okay, so let's see, we get 2 cosine alpha all over cosine squared of alpha. And of course, this guy will cancel off with one of those. Okay, so I end up with 2 over cosine of alpha. And let's see, that would be like 2 times 1 over cosine of alpha. So 1 over cosine of alpha is the reciprocal of cosine, which is secant. So I get 2 secant of alpha. And that's exactly what I'm trying to show. So we're good. Okay, that guy's down. Last problem of the week. Something tells me this guy's going to be very similar to the last one we did. Okay, so it looks like my common denominator here, I would get that by multiplying these two denominators together. So over here, above and below, I would have to multiply by 1 plus sine of alpha. And this guy would have to multiply above and below, okay, by 1 minus sine of alpha. Okay, so let's see. So the whole thing is going to be over the denominator that results from multiplying these two guys together. And notice they're conjugates, so that's going to give me a difference of squares. So I'm going to get 1 minus sine squared of alpha. Okay, so from over here, distribute the 1 there and distribute the 1 there, so it doesn't really change anything. So I get 1 plus sine of alpha plus 1 minus sine of alpha. Okay, so notice the sine alpha and the negative sine alpha cancel each other off because they're opposite, so I just add the 1 and the 1 and I get 2 over 1 minus sine squared alpha. Okay, and then going to our Pythagorean identity, sine squared alpha plus cosine squared alpha equals 1. And I want 1 minus sine. Okay, so I get cosine squared alpha equals 1 minus sine squared alpha. So again, I can substitute cosine squared alpha in here. And so I get 2 over cosine squared alpha, which is the same as 2 times 1 over cosine squared alpha. And obviously that is the reciprocal of cosine squared, so that would be secant squared. So we get 2 secant squared alpha. And that's exactly what we're trying to show. And we are done for the week. The quizzes were posted yesterday. They're due next Monday, just like always. So guys, be safe out there, and miss you a whole bunch.